Hey guys, and welcome to the factoring to find zeros lesson. We've already talked about how to find zeros by using square roots and graphing. Today we're going to talk about how to use factoring to find the zeros, and then we will move on to our last one, which is going to be quadratic formula. So remember that zeros are the x-intercepts of a quadratic function, and they're called zeros because you find them by setting the equation equal to 0. Because we are setting it equal to 0, we can use the zero product property. We had talked about this back in Unit 7. The zero product property says if A times B equals 0, then either A equals 0 or B equals 0. One of those has to be true. So when you multiply two things and it equals 0, one of them has to be 0. That's why it's called the zero product property. Product means multiply. Now, factoring helps us use this because we are rewriting polynomials as products using parentheses. So when you factor a polynomial, you have to have parentheses. And we're mainly going to be using one type of factoring today, and that is trinomials. When you are factoring a trinomial, there are specific rules you have to use, and that's what we're going to go over for most of the lesson. When you are solving by factoring, your two steps are to factor, then set each factor equal to 0 to solve it. Okay? When you are factoring, you are trying to find the two numbers that multiply to the last number and add to the middle number in that order. So we're going to list things that multiply to the last number and then pick the two that add to the middle number. And then just the last reminder for you is when two numbers multiply to 0, one must be 0. That is the whole basis of what we're doing today. All right, if you wanted to find the zeros of f of x equals x squared plus 17x plus 30, we need to find two numbers that add to 17 and multiply to 30. Things that multiply to 30 are 1 times 30, 2 times 15, 3 times 10, 4 doesn't go into it, 5 times 6. So you're just kind of making the left side go 1, 2, 3, 4, 5, 6 until you start repeating numbers, which I didn't continue to 6 because 5 is already on there. And then I'm just looking for the two that add to 17. That would be 2 plus 15 equals 17. Once I know that my numbers are 2 and 15, I put those next to x's in parentheses like this. Plus 2 plus 15. And then because I'm finding the zeros, this isn't f of x anymore, it's 0. That's what it means to find the zeros. And then my steps above were to factor. I'm done with that now. And then I set each factor equal to 0. So x plus 2 equals 0, and x plus 15 equals 0. Now those are both very easy equations to solve. You would just subtract the 2 and subtract the 15. So x equals negative 2 and negative 15. Please don't put parentheses around that answer. You can put a comma in between because you're just listing two things. But if you put parentheses, it makes it look like a coordinate. And it is not a coordinate of negative 2, negative 15. All right. Finding the zeros of the next one, I'm going to go ahead and start this time by writing that 0 and setting up my parentheses so that I am ready to go. And then I need two numbers that add to negative 11 and multiply to negative 12. When they multiply to negative 12, one of them has to be negative. I usually just make the first one negative like this. Negative 1 times 12, negative 2 times 6, negative 3 times 4. And then I'm going to add them together to figure out which one equals negative 11. Now, the top one equals 11, but I need negative 11. So what I'm going to do is I'm going to switch the numbers to positive 1 and negative 12 when I write them down, because that will add to negative 11. And then I solve both equations. X plus 1 equals 0, and x minus 12 equals 0. When I go to subtract the 1 and add that 12, my answers will be negative 1 and 12. Now, if the equation isn't set up like that, if it just says solve, you're doing the same thing, but this side has to be 0 first. So what you have to do is subtract the 15x and add the 2. When you write those on the other side, though, write them underneath their like terms. So when I copy down the negative 15x over to the left side, I'm going to write it underneath the 4x. And when I copy the plus 2 over, I'm going to copy it underneath the negative 30. So then that cancels that side out, and it's now 0. On the other side, the x squared will stay, and then 4x minus 15x is negative 11x. Negative 30 plus 2 is negative 28. And I'm going to go ahead and say that that was a typo, and this is supposed to actually be positive 28. I'm going to highlight that so that you remember to change it really quick. If you want to know what the original problem should have been, it should have been positive 30 and positive 2. And then you would be subtracting the 2 to the other side. You don't have to fix it up here, though, if you don't want to. Just letting you know that it's not going to work unless we fix it. There we go. The reason why is because I need two numbers that add to 11 and multiply to 28. Things that multiply to 28. 1 times 28, 2 times 14, and 4 times 7. Now, 4 plus 7 is 11. In order to make it negative 11, I want negative 4 and negative 7. So my parentheses are going to be x minus 4, x minus 7 equals 0. And then my answers at the end would be x minus 4 equals 0 and x minus 7 equals 0. To solve, I'm going to add the 4 over and add the 7 over. 0 plus 4 gives me 4. 0 plus 7 gives me 7. Okay, the only tricky part about this one is you had to move everything over yourself. All right, second equation down here. I've got a 2x squared that I'm going to subtract over underneath the other x squared. And I've got a 5x that I'm going to subtract over underneath the other x. The 36 will stay the same because there are no other constants on the other side. And now that means that we will have 0 left. Now, 3x squared minus 2x squared is 1x squared. You can write the 1, but you don't have to. And then 5x minus 5x is 0. So I just have x squared minus 36. Now, I'm actually going to solve this. I'm going to pretend like there is a 0x in there. I need two numbers that add to 0 and multiplied to negative 36, which would be 6 and negative 6. And then I would solve both of those. X plus 6 equals 0. X minus 6 equals 0. Which some of you might already know. That means my answers are going to be negative 6 and positive 6. You could have also used square roots to solve this one. You would have added the 36 to the other side, which would have given you x squared equals 36. And when you square root both sides, you would get plus or minus 6. Same answer. You don't have to do that, though. That's just a showing you that everything works together. All right, easiest two on the assignment. If you want to write the factored form of a quadratic with zeros at 5 and 7, that means that x plus something equals 5 and x plus something equals 7. Now, if I wanted to get I wanted to make that side 0 again, I would subtract the 5 and the 7. So x would be negative 5 and x would be negative 7. Or if you haven't noticed yet, every number down here at the answer was the opposite of the number up there. So those are opposites, those are opposites. And then if I wanted it to be negative 1 and negative 3 and positive 1, I would do x plus 3, x minus 1. So those are just always going to be the opposites. That's it. Now, to finish off both of those, if you need it to be a quadratic function, you need to either write y equals or f of x equals out front. I don't care. I think most of you will pick y equals, but you do need that to finish it off. Otherwise, it's not a function if it doesn't have an equation sign. That's it. That's all you have to do to write those.